Good morning, Year 11s. Welcome to solving quadratics by completing the square. Now, if you recall from the last video, when we aimed to solve a quadratic, we would convert it into standard form, factorize, and find a solution for each factor. However, we couldn't always factorize, so there are two options if we can't factorize. One is called completing the square, this video. The other is quadratic formula, which is the next video. Alright, so here we look at this, and our first thought might be, brilliant, let's try and factorize it. There's a 1 at the front, so we're thinking sum and product. What multiplies 11 minus 11 and adds to 6? Well, nothing multiplies to minus 11 and adds to 6. Therefore, we can't factorize. Alright, so let's try completing the square. Now, completing the square has the following steps. Those are the steps I've written out that I quite like following. There are the textbook steps here that essentially do the same thing. Alright, we need to rearrange into general form. Tick, done already. We need to ensure the x squared coefficient is 1 if needed. The x squared coefficient is 1. Tick. Halve the b term, add b on 2 squared, and take it off again. Now that seems quite odd. Here, the b term is this one here. Remember, a, b, c. So, halve the b term, b on 2 is 3, b on 2 squared is 9. Add this value here, and take it off again. Alright, let's look at what that means. X squared plus 6x plus 9 minus 11 minus 9 equals 0. Now, really, we've changed nothing about this equation. There's nothing here that's different. We just added 9 on, taken 9 off. Okay. Why have we done it? Well, why have we done it is to set up this here. Now, this here is quite a cool thing, because if we then try and factorize that, we should find that, well, what multiplies to 9 and adds to 6 is 3 and 3. Positive 3 and positive 3. That will always be a perfect square. Right? And note, the perfect square will have the number here that appeared up here. That value in there will always be b on 2. Alright. Then on the other side, we have minus 11 minus 9 is minus 20. So what we do is after we add b on 2 squared and take it off again, we have part of this that comes out as a perfect square, and the other part is just a constant term that gets simplified. Now, and that's what's called completing the square. That's this point here. Then we need to solve directly. And solving directly looks like this. We've just got one x term there. So if we're solving directly, we basically unwrap the x term, taking everything away from it. So x plus 3 squared equals positive 20. Add 20 to both sides. Square root both sides. X plus 3 equals plus or minus the square root of 20. And we should know that we add plus or minus on. Alright. Then take 3 from both sides. X equals minus 3 plus or minus root 20. And as your method students, you'd be expected to recognize that root 20 is really the same as 2 root 5. So this would be minus 3 plus or minus 2 root 5. And that's come from the fact that 20 is really the same as 4 times 5, which is root 4 times root 5, which is 2 times root 5. Alright, but that would be your two solutions there. And note that they're not whole numbers, but that you wouldn't expect them to be. If you could factorize it, then you get whole numbers. Here you can't factorize, so you're not going to get a whole number answer. Alright. So, let's follow the process through once more here, but here's not quite as pretty. This is the nicest sort you can get. This is a little bit uglier, but follow the steps and it works okay for you. Alright, we're in the right form. There's a 1 at the front. Minus 3 on 2 squared is 9 on 4. And I really would leave it as fractions to help you here. So then what we do is we have our x squared, take 3x plus 9 on 4. So we always add it on. Plus 1, take 9 on 4 equals 0. Alright. Then we'd think of this in halves. Well, this side here is going to be a perfect square, but it's ugly. However, we know that this will be x take 3 on 2 squared. And if we expanded that back out using FOIL, we would get back up to here. The reason we know it's 3 on 2 is because that's what the b on 2 was. Then we have to simplify over here. 1 take 9 on 4 is minus 5 on 4. Think of 1 as 4 on 4. 4 on 4 minus 9 on 4 is minus 5 on 4 equals 0. Then we solve directly. So solving directly, we have x minus 3 on 2 squared equals 5 on 4, which is square root both sides. X minus 3 on 2 equals plus or minus root 5 on 4, which you could think of as plus or minus root 5 on 2. The root 4 makes 2. The plus or minus you really only have to think about as applying to the top. Then get it completely myself. X equals 3 on 2 plus or minus root 5 on 2. Neat, huh? Last one, and I realise this is quite brutal for the video, but this is an exact question out of the textbook. Alright, here we need to do a few steps. First, we need to get it into general form. To get it in general form, multiply everything through by x to start with. So 3x squared minus 2 equals 4x. Then chuck everything on one side. So 3x squared minus 4x minus 2 equals 0. And here's where life gets really nasty, because we haven't had to do this step before. Ensure the x squared coefficient is 1. Down here, the x squared coefficient is not 1. Alright, so how do we ensure it's 1? Well, we ensure it's 1 by removing a factor of 3. And you might be thinking, 3 doesn't come out of 4 and 2, and I'd be like, yeah, you're right, but we can force it out, like this. 3. X squared minus 4 on 3, x minus 2 on 3 equals 0. And yeah, that's ugly. But if you think about the 3 coming back in, as it comes back in, you would do 3 times 4 on 3 will just leave you to the 4. 3 times 2 on 3 will just leave you the 2. So you can actually factorize out a 3. It's just not pretty. Alright, now we continue with the steps, leaving this 3 at the front of the brackets for whatever else we're doing next. Okay, so what are we doing next? Well, what we're doing next is grabbing the b term. The b term is minus 4 on 3, and then we're dividing it by 2. And then we're squaring it. So let's just simplify that to start with. Minus 4 on 3 divided by 2. Well, when you halve something, you're halving the top number. So dividing by 2 is the same as halving it, so that's really the same as minus 2 on 3. And so that would be our b on 2 term. And then what we want is the b on 2 squared, which is minus 2 on 3 squared equals 4 on 9. If you want, you can bring that out separately and do keep change flip. Alright, so here we want to add that 4 on 9 and take it off again. X squared minus 4 on 3x plus 4 on 9 minus 2 on 3 minus 4 on 9 close brackets equals 0. Alright, leave the 3 hanging at the front and now deal with what's in here. So once again it happens in halves. This half here comes as x take 2 on 3 squared. And you can sort of imagine that when this squares out, the minus 2 on 3 multiplied by itself will get you that positive 4 on 9. And then dealing with this. Well, this here is going to be minus 10 on 9 equals 0. Because 2 on 3 is the same as 6 on 9, so that's minus 6 on 9 minus another 4 on 9. Minus 6 minus 4 is minus 10. Fractions work is so important in methods. Alright, now what? Well, now this cheeky 3 comes back in to make 3 x take 2 on 3 squared. Note the 3 can't actually hop into that bracket because it's protected by squared. When you've got a power up there, you can't jump in first because you need to evaluate the power first. So the 3 can't go in until that power is multiplied out. Anyway, just leave it at the front. Then this here, minus 10 on 9 times 3 is the same as minus 10 on 3. You could write it as minus 30 on 9. It's the same thing. Equals 0. Alright, now let's add 10 on 3 to both sides. So 3 bracket x take 2 on 3 squared equals 10 on 3. And now we can multiply both sides by 3. X take 2 on 3 squared equals 10. Square root both sides. X take 2 on 3 equals plus or minus root 10. X equals 2 on 3, add 2 on 3 to both sides, plus or minus root 10. And completing the square can be quite a brutal process when you start like that. But that's a direct cut from the textbook. It's the level you're expected to be at. So remember, it's just a process, and even though it's kind of ugly, as long as you're good with your surds and your fractions, you can follow it through. Alright, hopefully that's given you some good notes to work off. I will see you tomorrow. Thank you very much.